Hello, I'm Tanner Bond. The work I'm presenting by myself and Charles Ling from Western University is on catching attention with automatic pull quote selection. If you've ever read a newspaper, you've probably seen a pull quote before. A pull quote is a span of text taken from the body of an article and presented in a more salient manner. Pull quotes are designed to attract our attention and keep us engaged in the article. They've also been found to increase enjoyment and readability, shape reader perceptions, and facilitate learning. What we're interested in is how we can automatically select sentences from an article that will make for a good pull quote. And while we're doing that, what can pull quotes teach us about reader interest? First, I want to get the experimental setup out of the way. For this new task, we create a new dataset. We've collected about 15,000 news articles containing pull quotes from a variety of news sites. For each article, we extract the body, which contains the sentences composing the article, as well as the actual pull quote sentences. In terms of evaluation, what we want is for our models to score each sentence of an article based on how good it would be as a pull quote. The metric we can use is the probability that a randomly chosen pull quote sentence is scored higher than a randomly chosen non-pull quote sentence from the same article. This means that a randomly guessing model will score 50%, while a perfect model should get 100%. This metric was chosen for a few reasons. One of them is that it's able to handle the highly imbalanced nature of our dataset. This comes from the fact that there are many more non-pull quote sentences than pull quote sentences. Now I'll present our 4 groups of approaches and the results in parallel, followed by human evaluation. We consider 3 groups of handcrafted features. First, we have our surface features. This includes the length of the sentence position, number of quotation marks, and readability. Then we have our part of speech features. So we compute the density of a variety of part of speech tags in sentences. And then we have our affect features. This includes things like positive and negative sentiment, valence and arousal, and concreteness. Concreteness refers to how physical a word is. So it's the opposite of abstract. When we look at the surface features, we find that quotation count performs best, followed by reading difficulty, as measured by the proportion of difficult words. And when we dig into these features, we find that 2 quotation marks is best, and pull quotes should have better readability. When we look at the part of speech tags, we find that pull quotes tend to include more personal pronouns and verbs. When we look at the affect features, overall we find that they perform quite poorly, except for concreteness. And in particular, we find that pull quotes tend to have lower concreteness. That is, they're more abstract than non-pull quote sentences. Next, we'll look at our Engram features. So we consider character level and word level Engram text representations combined with a logistic regression classifier. For the character engrams, we find that it works best when we use n equals 2, so character bigrams. And for words, we find that the best performance is achieved with n equals 1. So for the character bigrams, the performance we achieve is actually better than paying attention to only the pull quotes, to only the quotation marks, And when we look at the actual weights learned for the engrams, some things we find are that pull quotes tend to use direct quotes, as we've seen before. They tend to avoid URLs and Twitter handles, as well as past tense, as indicated by ed at the end of a word, and they also avoid numbers and dates. Next, we'll look at combining deep pre-trained sentence embeddings, sentence BERT in particular, with a progression of neural networks. And we consider three groups of neural network architectures. In Group A, the only input to the network is the sentence embedding, and it's passed through an optional densely connected layer. So we have a basic version with no hidden layer, and a deep version with densely connected layers. In Group B, we concatenate sentence embeddings and document embeddings before passing them through the optional densely connected layers. Here, the document embedding, or the embedding for a whole article, is simply the average of the sentence embeddings. And in Group C, we combine these sentence and document embeddings in a mixture of experts fashion. The motivation for this is that it would allow us to more explicitly learn article topic-specific patterns. For example, maybe in political articles, it's more important that a pull quote refers to platform details, whereas in a cooking article, maybe pull quotes should be focusing on properties of ingredients or something. Overall, what we find is that using document embeddings does help, especially with mixture of experts approach. And this is true even when we account for the number of parameters. We also find that the deeper models within each group perform better. In particular, our best performing model is a deep mixture of experts approach with 4 experts. Now we'll look at our cross-task models. The idea here is that we construct models for related tasks and apply them to pull quote selection. The better the cross-task model performs, the more it suggests that pull quote selection is similar to the other task. So look at how similar pull quote selection is to headline popularity prediction, clickbait identification, and summarization. The reason these 3 tasks were chosen is because, well, for clickbait, clickbait is designed almost exclusively to attract our attention. Headlines are also designed to attract our attention, but also be informative of what's in the article. And summarization aims to show us what is most important in an article, and we guess that these properties might overlap with what makes for a good pull quote. When we consider the results together, we find that it's more important for pull quotes to be engaging, like clickbait, than to be informative, like headlines or summaries. But we find that the performance of these cross-task models is much lower than the pull quote specific models, indicating that there is probably more to pull quote selection than just what is suggested by these cross-task models. Now we'll look at human evaluation of our approaches. So we take 50 random articles from our test set and generate 6 candidate pull quotes per article using our approaches, as well as the true pull quotes. And then we ask our participants, for each candidate, how interested does the pull quote make you in reading the rest of the article? And they were asked to provide a rating for each candidate from 1 to 5, where 5 is best. So when we look at the average rating for each approach, we find that the character bigram model performs best, followed by the true pull quotes and the deep mixture of experts approach. when we rank the candidates for each article, we find that the character bigram model again performs best, followed by the true pull quotes and mixture of experts approach, with the cross-task models relatively far behind. And then when we look at how often each approach produces the best candidate for an article, we find that the character bigram model is on par with the true pull quotes, followed by the mixture of experts approach and the clickbait model. And the worst performing model tends to be headline popularity. Now I want to summarize the lessons that these approaches have taught us about what makes for a good pull quote. So first, we've seen that pull quotes tend to use a direct quote. They should have high readability, so this is avoiding long or uncommon words. They use more personal pronouns and verbs. They tend to be on more abstract subjects. And they tend to use messages related to two or more of the following topics: morality, difficulty, politics, danger, and so on. If you're interested in how we came up with this list, you can refer to the paper. Pull quotes also tend to avoid numbers and dates, URLs and Twitter handles, and tend to avoid past tense. And some of the aspects you cannot, or you don't need to worry about, which one might think makes for a good pull quote, are using lots of adjectives, adverbs, or nouns, trying to be exciting, trying to summarize the article, and having a positive or negative sentiment. So to recap, we've presented a new task called pull quote selection, which can help us understand how to attract and maintain reader interest. For this task, we've created a new data set of news articles with pull quotes, and we've benchmarked and examined a wide range of approaches. If you're interested in reproducing our dataset or results, the code is on GitHub. Thanks for listening.